So good morning, Lana, and welcome to today's science lesson. Now just to remind you what we are doing in our previous lessons. Last week we were doing friction, and in friction we talked about the definition of friction. We also talked about ways of increasing friction, talks about ways of decreasing friction, and today we are moving to something different, that is levers. So you want to know what levers are? I told you that today we will have a very interesting lesson where we are going to know more about levers. So you're going to realize that a lever is any machine that is used to make work easier. Levers are simple machines that are used to make work easier. Remember, I'm saying making work easier, not reducing the amount of work. So that if we are carrying a load of 50 kg, when you use a wheelbarrow, you just make the carrying of that 50 kg bag easier compared to when you are carrying it physically using your maybe arms or even at the back. So we are not reducing the amount of work to be done, but we are making it easier by using a machine so that it becomes easier for you, and therefore you are applying less effort. So that is exactly what we are saying. So in simple terms, a lever is any simple machine that is used to make work easier. Now, a lever has parts of levers. So we are going to see three parts of levers. Why the lever is making work easier? Because of these three parts. Number one, we have what we call the load, and this is the force to be overcome. The other day I gave you an example of a wheelbarrow, and a wheelbarrow is a good example of a simple machine. So if we have a wheelbarrow, a simple wheelbarrow like this, that is a simple wheelbarrow. You place your load here, so this becomes your load. So that becomes the load. What you are carrying, the work that you are doing, becomes the load. So load is the force to be overcome. I'll tell you why I'm talking about load being the force that is to be overcome by the effort. In this case now, I'll show you what the effort is. Now the effort is the force that you apply, and the effort is being applied there. You're going to lift the wheelbarrow so that you can overcome that lifting up, because this load is pushing it downwards. So you have to apply, remember what I told you, for you to be able to overcome an incoming force, you must use an effort that is more, or the force that is more than the incoming one, and should be opposite direction of the incoming force. So if the weight is pressing downwards like this, then you apply the opposite force to that direction so that you can overcome this weight. And this force must be more. That's why I said a class 2, grade 2 child cannot be able to carry 100 kg bag of maize, because this force is equivalent to that class 2. So the force that the person is going to apply here is less compared to the load that is going to carry, which is a 100 kg bag of maize. So we are saying this becomes the load. So the load is to be overcome by this effort. So the effort must be higher compared to this load. Now let's see what the effort is. Effort is the force used to overcome the load. So this is what we call the effort. Where you apply your force, where you applying your effort. That's what we call the effort. You can have that. You can also have. I'm not a good artist, but something you have seen many times looking like this. Assuming that is a pair of scissors, your effort is being applied at this end. That is where you hold while you are shaving sample. And the load is what you are doing here. Load is the air in this case. You are cutting the air, or whatever you are cutting becomes the load. So you are using this effort to overcome this particular load. Then we go to the last point, which is the fulcrum. I told you we have 3 points in a lever, the parts. The fulcrum, the rotating or turning or the supporting part or point. The turning point, rotating point, or the supporting point. Turning point, in this case, I want you to look at this wheelbarrow. This is the part that turns. So this becomes the fulcrum. That becomes, in that case, the fulcrum. So the fulcrum is where the simple machine turns from. This is the part that rotates. If you look at this pair of scissors, this part is the one that turns. So that becomes the fulcrum. Most of the time you denote it at using the letter F. But again, if you look at this one, learner, if we have another type of machine here, I've ever taught you about this, and I'm happy because the paper that I gave you the other day had this question. And so, what is to be lifted? First of all, this is called a crowbar. A crowbar is just a simple machine where you have a piece of wood, a straight one, you have a supporting part, maybe a stone, and you want to lift another part. So this wants to be lifted. So this is the supporting part. So this becomes the fulcrum. Where you applying your effort? At this point. So you're pushing downwards. You place it like this and you push downwards so that you lift this load. So this becomes the effort. So the reason why I'm talking about the supporting. The supporting part, because this only supports, does not rotate. It only supports. So this becomes the fulcrum. But this rotating, then we have also the turning. Rotating and turning simply means the same. So you have understood the 3 parts: the load, effort, and fulcrum. Fulcrum is also called pivot. You can also call it pivot. So fulcrum, the other name is the pivot. So pivot is this support here, the one that you use there. So that is exactly what we mean by levers. So levers are simple machines that are used to make work easier. We don't reduce the amount of work I've said, we only make it easier. When you use a wheelbarrow, it's very easy for you to push that wheelbarrow and carry a 20-liter container of water from the taps to where you are taking it to. So it becomes easier for you other than when you are just lifting it and using your hands to push it, to carry it. Then you have the parts. So the load is the force to be overcome. And for you to overcome this load, you must use effort. And the effort you use must be higher than the force of the load. And then we have the fulcrum, which is the turning point, the supporting point, or the rotating point. So that is exactly what we are talking about. We also call it balancing point. The fulcrum is also called the balancing point. The part that balances. Like in the case of a seesaw, so this part is placed there to balance. It's a pivot and that's where it balances. So from this side to this side, if this is 5 centimeter, this also should be 5 centimeter. That's what we use when you're talking about the beam balance, when you talk about the seesaw, the balancing point. So from there, now we're going to classify levers. classification of levers. Classification of levers. Going to be our next point. Classification of levers. This is going to be a very easy task for us to be able to classify levers. We are going to classify them into three main classes. So levers are classified. Levers are classified into three main classes, depending on the position, position of the fulcrum. So we look at the position of the fulcrum, at the position of the fulcrum. So these three classes are going to be named according to the positions of the not fulcrum, but of the parts. Sorry, position of the different parts. So in this case, we have already known what the parts are. We have the fulcrum, the effort, and the load. So according to those three parts, now we are going to classify levers. And so we are going to have three classes of levers. And the first class levers, first class levers. How do we know a lever is a third class lever? Learner, for us to be able to classify levers so well, we understand that any lever where the fulcrum is at the center, any lever that we have the fulcrum at the center, that it comes as first class lever. I want to give you an example. Fulcrum, we have said, is a rotating part. So a good example is this, what we did here. Look at the fulcrum. The load is here, fulcrum at the center, and the effort on the other side. So this is found at the center. So a good example of that is e.g. a pair of scissors. And I want you to draw a pair of scissors here, Lana, so that you don't confuse anytime you're given a question like that. I'm drawing a very simple type of scissors. So this is a fulcrum, right F. This is a load where you have the air, and this is where you apply your effort. So in this case, you can be able to see exactly where the fulcrum is. So whenever the fulcrum is in the center, then that becomes first class lever. So we move to the second class of levers. That is going to be second class levers. The second class levers. Second class levers. Now second class levers, we classify them to be second class levers because the load is always at the center. The load is at the center. I want you to look at this pair of machine and this type of machine. This is a wheelbarrow. Look at it well, Lana. So the load is here. What you are carrying is there. So this becomes the load. You are applying your effort here, and you are applying it upward. The load pushes downward, and this is the fulcrum. So where is the load? The load is at center, and so a wheelbarrow becomes a second class lever. We are going to see others which are in the same class as wheelbarrow. That is second class lever. And then we go to last part, which is going to be third class levers. Third class third class levers. So in this class, first class levers, effort is at the center. The effort is at the center. Any lever that you are going to find that the effort is found at the center, then that becomes a third class lever. I want to give you a good example that you know. If you have a fishing rod looks like this, then the string is there, and then our fish is there. This is the work we are doing, removing the fish from the water, what we call fishing. So this becomes the rod. Where are you holding, Lana? When you are fishing, you hold it like this. So this back hand, this one here, its work is just control this rod. So the work is done by this particular hand. If you are left-handed, you hold it like this. But this particular hand is the one that lifts the fish from the water. So this becomes the effort, where you are applying your force. This one, there is no force you are applying. Your work is just rotate it, change it. So this becomes the fulcrum, and this, the one that lifts the fish, become the effort. So the effort is found here, where you are holding this, and then at the back here, where we have the fulcrum. So now where we have the effort at the center, that is a good example for that class level. So now we have been able to classify. We defined what levers are. Then from there, we saw the parts of levers, and we will be able to use those parts of levers to be able to classify the three types of levers. So in our next lesson, we will have a very simple task to be able to place a number of levers in the three different classes of levers. So be there in our next lesson, and we will enjoy, I know you will enjoy the kind of discussion that we learn. Have a blessed day, and may God bless you. Take note of this, what you have done in your book, and let me see what exactly you are doing. After you are done, you just send it to me so that I can be able to see what you are doing. Have a blessed day ahead.